So hi, everyone. My name is Carl Moll. I'm the technical project advocate here at FINOS. Welcome to the second in our open source and finance webinar series. We are very excited to have Jeremy Taylor, the head of product from JUXT, joining us today. Jeremy, with the JUXT team, was very active in our TraderX tech sprint over the summer in Q3 going into OSFF NYC, where they had a very great bitemporal database integration with TraderX for looking at time series analysis on trading data, which was a very exciting project and had a lot of interest from the community. And Jeremy was just a real pleasure of a team participant to work with. So very excited to be able to see what they're presenting with us today. Just before we get started, just a reminder that this is the Open Source and Finance webinar series is a member benefit. So if you are a member who has an open source project that you would like to highlight and you think would be of benefit to the community, please contact us and we will be more than happy to start a conversation about how we can promote this to the community using this format. With that, Jeremy, over to you.
Awesome. Thank you, Carl. And good morning, good evening, everyone. Yeah, it's really great to have another platform. I was at the OSFF conference in New York just a couple of months ago. Yeah, appreciate everyone dialing in for this. So the topic of the session, accelerated as of reporting, it's quite an abstract topic in a sense. Like a lot of people don't really think of this as like something necessarily to talk about all on its own. But I think as with many things in IT, it's good to zoom in on one specific issue and pain point. And that's really what my story is. I've been working at JUXT for almost 6 years now, mostly on this point, right? So this has become a bit of an obsession. But before we get into a bit about my background and what accelerated as of reporting is, let's just talk about JUXT briefly. Here we go. JUXT is a consultancy. We've been working mainly as software engineers, augmenting startups and scale-ups and tier one investment banks over the last 10, 11 years or so. It's been an interesting journey. So JUXT was founded by a couple of guys who worked at investment banks previously and subsequently got involved in the Clojure ecosystem. So Clojure is a functional programming language. So there's a lot of hard technology people in JUXT, and a lot of our pedigrees around building systems related to risk in these investment banks, specifically something like a structured products platform. In one case study, we used JSON schema and built a large system or application for structurists to create new products, define barriers and knocks and all these other sophisticated things, and do that without having to wait for development teams to turn around those changes. Very complex data models and a lot of complex code as well to support it. But JUXT has been doing a lot of other kinds of projects over the years, and that's really what I want to tell you about. The only other thing to note is that JUXT, as of a couple of months ago, is now a grid dynamics company, and Grid Dynamics is a publicly listed global technology consultancy that's been going since 2006, working with many Fortune 1000 companies on things like digital engagement and machine learning engineering, and has presence in over 18 countries. But JUXT has, as you may tell from my accent, a pedigree in London, where we mainly operate out of. So in the course of JUXT's experience, and this is before I joined even, the founders were very keen on studying the problems that we were finding in these different accounts we were working in. And a few of the problems that I think are worth highlighting, and you can break these down in different ways, and they intersect in different ways. But and you may think in terms of risk mitigation or cost savings or time to market. But if we think more concretely, we've observed that organizations struggle with high costs to deliver timely reporting and reproducibility. So the high cost may be born from the infrastructure costs, but it may also just be the amount of work done every time a new feature or system is rolled out, the work done to support the reproducibility or the auditability of that. So that's a big barrier. Another would be the work done in migrating data between systems continually for doing ETL work to extract data and insights from existing applications. And then finally, we'd say that just this general move away or trend away from SQL databases. And this was, of course, popularized last decade with the NoSQL movement. But in more recent years, even though there's been a bit of resurgence in interest in SQL as an API language for databases, people still really struggle with applying it in complex financial domains where you don't always have complete control over the schema. The schema is also incredibly nested. And yeah, there's always been this impedance mismatch we've observed. And so, of course, these problems are always worked around, and we have observed those common workarounds for these problems. Some people take the approach of just log everything, log all the changes, but then you end up in trouble with the regulators or auditors who then come along and say, how are the logs actually stored? Do I have to trawl through lots of tape archives and reconstruct complex application states in order to understand what's happened in the past? Another approach is database snapshots. So many databases offer snapshot capabilities, but they lack the ability to execute quickly. You can actually delay the processing of reports and analysis based on those snapshots because the snapshots take so long to generate. They can also consume a huge amount of space, and the frequency of the snapshot may not actually match the business requirement. And that could happen retroactively. So you could discover, actually, no, we really needed that intra-hour snapshot, but we only had daily snapshots. And how we're going to, we've lost the history at that point. How are we going to recover the situation? Another workaround we often see is change data capture. And this involves taking the output of your favorite SQL database, whether it's Oracle, Postgres, etc., and piping that maybe via Kafka or Debezium into a Snowflake or a large analytic warehousing system or a data lake. And this is a common strategy, but of course, as many people that have tried the data lake approach found it requires actually a lot of ongoing work to maintain an understanding of what's inside of that data warehouse or data lake or data swamp even. Otherwise, you will be unable to actually query it. So you end up, in many ways, reproducing many of the application logic, the application schemas, application queries in the data warehouse or on the data lake in order to do that analysis or fight against that pain of not being able to understand what has happened in your application. And then the final thing that is maybe more typical is just to work around the lack of versioning in your data, and you just add extra fields, extra columns in your tables, or you have an audit table and a normal table, and you migrate the data around at the database layer or in the application layer and right down to multiple tables. And these are what we consider workarounds. None of those are very satisfying options, and they all come with many trade-offs, and many of them are used in conjunction as well. So the team at JUXT, including myself and a few others, we sat down and we built a database, which is a bit of a large undertaking, and I can explain the history of that and technically what that's required a bit later on. But suffice to say, we built something called XTDB, which we launched in 2019. It's open source. PL licensed. It solves this problem of how do you understand what has changed in your application in a fairly neat way, I think. And we've been working with various organizations. Many of them are way outside of finance even. So, for instance, Cohesive here work on cardiac healthcare software. And it's very important for their clinical users to be able to prove what they knew and when they knew it, so that if someone comes and tries to understand why did you make this decision, and something ends up in court, that they can prove exactly what the state of the system was when that decision was made. And another example would be a retailer in France who had this pricing system, and they needed to model the future validity of prices in order to incorporate things like supplier discounts and promotions. And that complex future pricing data was also needed auditability in case the regulators again came in and said, where's your report that proves you're not price fixing or getting the prices wrong and doing something that's anti-competitive. We've worked with organizations working with blockchain systems who have this sort of very immutable view of history already, but they lack this inability to query as of and align different timelines from different blockchains. There's a security vulnerability tool that the Dutch government initiated called OpenCat, which is all about gathering data from scanning software. So if you've got networks that are all connected, you might want to scan those and understand how the network configuration changes over time. And again, this is something we've been collaborating with. But all of these implementations, all of these different projects have been really inspired by our work in financial services, where we first discovered this word, bitemporal, and we'll come on to what exactly that means and entails. But let's just step back a second, because this is quite in the weeds of what we've been doing as an organization. And let's look at what is the commonality between all of these use cases, all of these requirements that people have. And it really is as of reporting. And you might be asking, why does this really matter? I think it's actually very fundamental to how we think about data and make decisions based on data. And what's common in all of those circumstances is that you have some kind of user, some sort of decision maker. And increasingly, that decision maker is going to be an AI agent of some kind. It's going to be an algorithm making decisions. And what's necessary is that you can prove exactly what that agent, that user knew at a given moment, so that you can introspect that decision making, you can challenge it, you can improve it maybe. So it's not just internal managers. It's not just internal auditors or industry auditors or regulators. It's everyone really wants to understand why different decisions were made and be able to reconstruct the state of the system at that point in time. And it's also particularly challenging when there's not just one source of truth, right? If you just have a domain where all your application state is in one giant database, maybe this is not that hard a problem. But where it really becomes a challenge is in this polyglot environment where you have many different systems and different servers, and everyone's got their own sense of timestamp. As of reporting is really just a mechanism to make sense of that. So it provides the auditability and gives everyone that confidence that things are as they should be. And also, as I said, that they will be as they should be. So as I said, in like a retail scenario or many other scenarios, you may have future dated changes to your data, and you want to give everyone the confidence that those future changes are going to line up and coordinate, and you want to run an as of report with those planned changes or hypothetical changes. So broadly speaking, everyone needs as of reporting. And so when I went to the FINOS conference in London over the summer, I heard a little bit about TraderX then, and then the tech sprint that Carl mentioned earlier was announced, and I thought this is a great opportunity because TraderX does not have any sort of reporting capability. If you take a peek under the hood, it's a SQL database H2, which just has a lot of as of now tables, right? You change the state of the trade and the old record is gone. So it was very ripe for us to come along and do some clever integration work to show how you can take a system like that and add as of reporting to it. My colleague Nihal and I and a couple of others, we sat down for a few weeks and tossed this idea around how we're going to make this work. And I can show you that now. So I'm just going to drag in this video. Hopefully you can see that okay. So this is a pre-recorded video. What have I just done? I have turned on the minimal interface. Okay, so I'm just going to play it and scrub through to show you what the end result of the TraderX sprint was. So this is the sneak preview of what it ends up looking like. But before we get into exactly what all the bits on the screen are, let's just talk about the nature of TraderX. So TraderX is very much a sample app. It's much more like a pet store than a real application in a sense, but it tries to be representative of how a real system might look. And it's designed for, like say, young graduate developers entering the industry to get a handle on what components are necessary in a trading system, but also as a training ground for making changes to add the latest DevOps and infrastructure or rolling deployments, etc. So it's a bit of a proving ground for different capabilities and technologies. So we took the code base as it was, which is this microservice-based architecture. And as I said, each of these microservices is backed by their own databases. Actually, it's just one database, but the tables are completely separate. They may as well be separate databases for each microservice. And this is a very common pattern. And the challenge is, how do you aggregate data from across many microservices to run reports? Because if you have to go from one microservice to run like a sort of report and part of the state and then go to another one, you have this risk that things have gotten wildly inconsistent between running the report over there and say on the position service and then running the report in the trade service. So the challenge is, how do you run reports across an entire microservice system? So what we did was to add another reference service in this design, which would ingest data from all the different services asynchronously, and then allow you to run reports, but as the user, right? So this isn't like an asynchronous thing that an analyst would do. This is like part of the application. So in the application view here, we can see that first of all, there's no pricing data, so we had to add some pricing information. But also, we only just have the two tabs for our blotter, so current trade view of our current portfolio and some account information. So what we did was to fix those things first of all. So we'll just scrub through a second. So we added the ability to buy and sell at different prices, which of course is necessary in order for us to talk sensibly about as of pricing data. And then, we have some extra information in the blotters themselves, display the closed positions separately. And we're actually able to track the different states of the trades over time. But this is still behind the scenes. So the trade view is always showing the as of now view. If we want to see this trade view as of different points of time, we added this reporting tab. And the reporting tab has a slider at the top, which allows you to go backwards in time. And it really, what I'm talking about when I'm saying as of reporting, it's taking any application, any screen that you can imagine in any application and having a slider on it, just like this, that allows you to scrub through the history, not as a developer, not as an analyst that's working days later in some business intelligence report. This is for the user to understand how their data has changed in real time and then make decisions based on that. So in this example, we can see the states of the trades are moving from, say, pending to settled, and we're also updating then the current positions. And there are many calculations and other mechanisms you can hang off of this. So for instance, if you wanted to run a long-running risk report or do some risk calculations, which may happen in big batch jobs that you have to spare up compute clusters, etc., and Monte Carlo simulations, you want to be able to version precisely all the inputs to those calculations and then obviously store the results as at a point in time. And so the principle here is that all of this information can be stored in a way that then you can report on and scrub through. And as you just saw, we have this pricing slider as well. So not only can we take the entire application and scrub through time, but any particular subset of the data, which also has some time definition in this case. Let's say, what would the state of our portfolio had been if the prices had reflected another point in the time series? And we can combine these two as of queries into a single view of history. So anyway, this was the output of the tech sprint. We added some reporting tabs, and yeah, that's pretty much all there is to show you on that. And before I get into exactly how we built it, I will flip back to the presentation. Okay. I will just pause just for water if there's any questions, Carl, dish up. And as Carl said, interactive is good. So if you have questions, we'll try to do them live.
Nothing in the Q&A so far.
Fab. All right. So that's TraderX. I'll tell you more about how that was put together. But there are many approaches, right? So what we've built, XTDB, is not the only way that people think about this as of requirements. Actually, a lot of very large, successful companies have been building these sorts of capabilities for years. So KDB goes without mention in this sector. That it's very powerful technology. It's been thinking about bitemporal data since the mid-90s. Then you've got established SQL vendors like Teradata who've added temporal table support. There are various approaches to this, but the common pattern is that a lot of the thinking here is quite limited, or it's about solving a particular pain in one place. Oh, I have some reporting pain on this type of data for this use case, and therefore I'm going to do something to anticipate those requirements and solve them in that one instance. And I think time series databases are very typical of this, right? So you have things like, here, DuckDB, Snowflake, which can handle time series data just fine, and QuestDB, QuestDB is trying to take that KDB market share, and they've added this thing called an as of join. And the idea with an as of join is you can take time series data. So time series being event based. So at this timestamp, something happened. And of course, not all data is modeled like that, right? So certain data is tick data, of course, is most famously modeled like that. And if you have the right amounts of tick data and in sufficient scale, then a time series database with as of joins is a very effective approach to meeting these as of requirements. And yeah, you can be fairly sure that if your database has an as of join, that it is not a bad place to solve these as of reporting requirements. And the way it works in particular is it takes something called a left lateral join. In other SQL systems, this idea of a lateral join, and it makes that a bit simpler to read and to reason about. But most importantly, under the hood, there's an execution speed up. The internal relational operator is very specifically engineered to accelerate this as of query. And that's actually a really key part of why this is even an interesting enough thing to add to these different engines, because without that, the lateral join would be probably very slow. So anyway, that's a brief summary of the way a time series database approaches the as of requirement. It's something which can take two tables and match the rows in those tables based on the latest version of a timestamped event in one of those tables, and give you a join across them. But it's something you have to write into your query quite explicitly. And crucially, it only works with events. So what is the other approach? The other approach is to use what we call a bitemporal database. And this was defined mainly in the 90s, but the original author who wrote the book on bitemporal databases, Richard Snodgrass, he wrote this paper in 1988. But even since a relational database was first conceived, people have been thinking about how do you incorporate time into databases. And the bitemporal model is one of the more general approaches. So unlike a time series database where you just have an event that happens at a point, in a bitemporal database, you have some state, and that can take these units, what we call chronons, which is a very philosophical language, but it has a duration, so start and end. So it's a different way of thinking about how time should be structured. But crucially, it gives you a lot of flexibility. So it actually allows you to go back and correct data or handle out of order changes, late arrival changes. Whereas in a time series database, you'd be quite limited to how much retroactive correction you can do. And you can maybe cope with some out of order ingestion up to some watermark, perhaps. But a bitemporal database gives you this very open, very flexible model of how to arrange your data on a timeline. So before we get into exactly how that works, I just want to really describe how I think about the word bitemporal, because I think it means two things. It means one, safety, and the other, correctness. And to understand the potential, I think, that a bitemporal database can bring, you have to look at what complexity exists in your organization. And I think in many systems, time will come up as a requirement, as of reporting will come up as a requirement. But is it core to your business problem? Is it something you really want to be solving in your application roadmap? So one way of framing this is you have these different sources of complexity. You may have essential complexity, and there's only really one source of essential complexity, and that's your code, your business logic. But your code may contain other things which have absolutely nothing to do with the business logic and are there for meeting other kinds of requirements. And a project may have many kinds of incidental complexity. Here's just a smashing of examples. But all the ones I've highlighted in yellow here have something to do with bitemporal requirements or reporting. And wouldn't it be nice if you could just never have to think about all these sources of incidental complexity, at least from the perspective of as of reporting, just by using a different database? And that's the question we've been working with our users in, as I said, for the last few years, trying to understand really the potential of making the bitemporal model more mainstream. So bitemporality is a combination of two timestamps. One is the time that the data enter the system. The other is the time that you care about, the reported time, the event time, the domain time. And these really line up with safety and correctness. So you have the system, the time at which the system was aware of something, and you can feel safe that the developers, if they've made a mistake in some application code, you can see how the data has changed. You can roll it back if necessary. And that's really the timeline of the system. So we call it system time. And then the reporting timestamp, this is the thing that you may want to change. You may realize there's been some error and you want to backdate some change and restate something which had some typo in or something like that. So this is about being accurate or correct. This is the thing that actually users want to care about. Users don't care about the time that some data entered the Kafka event log. They care about the timestamp that something happened on their application screen, right? These business timestamps. And having a very clear separation between these timestamps is really important for making sense of the world. Another thing I like to try and add to this conception of bitemporality is thinking about how we reason about things as humans. And of course, we have all these sensory inputs. You can think of ourselves a bit like a risk system. We have all these inputs and we're running these calculations in our brain to try and align these different temporal coordinates from when we hear something, from when we see something with the left eye, see something with the right eye. And we're trying to make sense of that. Of course, there's a lot more subtlety in what goes on in the human brain. But what I think of bitemporality as is giving your application the ability to process its environment, essentially. And the thing that's doing the processing may be the user. It could be some AI agent. And really what you want is systems that close the feedback loop as you make decisions, that the knowledge that was captured at the time of that decision is kept as close to the system as possible. And then the future iteration of that user, someone that's a manager's brought in a new person, they want to improve a process, or the next version of the agent, you want to backtest some change to an algorithm. You can do that by keeping the results of the previous decisions and the context of the previous decisions as close to the application as possible. So the whole vision of the bitemporal database really is about, or at least my vision for it, is about closing the OODA loop, which is come from the US Air Force, who sort of view decision-making in this process, or have done, of observe, orient, decide, and act. And if you can do those things more quickly, your applications can become, let's say, more AI-enabled. Anyway, so I only really got involved with FINOS a few months ago, and it was actually after going to the London conference and seeing Organization Premier Lab talking about bitemporality on their chart here, on their slide. And it was a few times during the conference where I heard this word pop up. And I've been aware of the pedigree in financial services. Not, to be clear, it's not my personal background. Like, I'm much more just on the pure technology side, and I've done e-commerce and retail things before. I have never built a risk system, but obviously in the course of my role now, I'm working a lot with people that do build risk systems. And just seeing the number of people still interested 30 years after the word bitemporal was coined, still talking about this topic as if it's an unsolved problem. And I think it is unsolved. And that's why we're still going. So here we have Premier Lab. We also have other examples. Already seen Finborn and Beacon on the slide. Here's one around a diagram from a website around investment book of record, position extraction. So you can see there aligning different timelines is really important. And we're not the first group of technologists to think, yeah, this is quite an important problem. But most people are focused on streaming systems or, let's say, analytics purely. So in the case of ArcticDB, they have a data frame database which can do some bitemporal stuff, but it's really just about managing these large data frame data sets. So it's not for building an application on top of. Event processing systems do have this idea of processing time and event time, but they always limit you to a watermark, right? So it prevents you going back too far in the history of a system to make changes. And it's not designed for point queries. They're designed for doing streaming joins. And people have built lots of ORM type kind of technologies. So Goldman Sachs have built something which does a bitemporal annotations around your Java beans, that kind of thing. And there's a reasonably popular Postgres extension called PG bitemporal, which is used by DRW, I believe, to track all kinds of things that people want to do in Postgres in a bitemporal way. And to be clear, that's not again talking about time series. That's talking about having regular looking SQL tables, but adding this temporal versioning capability. And then, of course, you have lots of time series vendors. But just to be clear, I'm not talking about time series as such. We are talking about something different. And to bring that to life, let's talk about the SQL specification, because I think it's the best way to visualize the bitemporal model objectively. And in 2011, so just over 13 years ago now, the new standard was defined, which included temporal table support. So you may have seen the Teradata in the previous slide. Teradata implemented their version of temporal tables actually slightly before this, so they don't even follow the standard. But even though this thing has been out for 13 years, many databases haven't implemented it. And it's part of a chicken and egg problem, I think, because the standard itself didn't get many things solved. There's a lot of open questions about how to implement it. And because of that, people aren't really able to adopt it. And you have to constantly think, do I want to use this temporal table capability in my application in this very narrow and constrained way? So there's been a few people that have been writing about this. Paul Youngworth in particular. Actually, he's just been landing some commits into Postgres. So he's now a seasoned Postgres committer. So there's a good chance the next version of Postgres will actually add some temporal table support. But he's been surveying this space for a long time and trying to understand why different vendors haven't implemented it and looking at the gaps in the API implementation. So do check out his blog if you're curious about that. And what we've done with XTDB, and this is a relatively recent thing for version 2 of XT, which we've only really launched in the last year. And even then it's just a beta and we're still wanting to iron out some stability, performance, functionality concerns, which we want to make sure it really works for our users before we say yes, it's generally available. But we've been working with a number of users already, and version 1 did exist. It was a Datalog API, if you're familiar with Datalog. So it didn't have SQL. Version 2 has SQL, and we've implemented SQL 2011. And what we've done is to do that in a way that's ubiquitous. So unlike what the SQL 2011 standard describes, we implement it across every table. So you never have to think, is this table bitemporal or not? All the tables are bitemporal. And this would be so hard to do with Postgres. That's one of the reasons why we didn't just build our own Postgres extension. We want to reduce the complexity, reduce the incidental complexity of your applications and the administration of your systems, to never having to think about when was this data changed and why was it changed. We really want to push all of that down into the SQL database layer. To summarize why we've built it, it's really, we think there's a huge data compliance problem. Again, not just in finance, it is everywhere, but I think it's most painfully felt in financial services, where we do make sure everything has strong auditing and reporting capabilities, but we spend a lot of money to do it. And wouldn't it be great if we could reduce that cost by, again, pushing that down into the database? But we've also tried to tackle some adjacent problems. So one of them is around schema management. And this kind of touches on the ETL thing I mentioned earlier about you've taken all of the data out of your application transactional database, put it in an analytic system, and now the transactional system changes. How do you keep these schemas aligned? And basically, you really just want your transactional system to be able to cope with these evolving schemas. And so that's one of the challenges we've been tackling as well. So SQL 2011 then, what we've implemented, this is a railroad diagram of the grammar. So every single table has this ability to do for valid time as of, or for system time as of, or for valid time between timestamp A and timestamp B. And all of this is transparent to the user normally. So if you're querying your table, you're always seeing it as of now. It just happens that the previous versions are there in the background. And this is actually the opposite of the way SQL 2011 standard defines it, where they make all of history visible by default. And there are these ergonomics or UX concerns, which we think they got wrong, or they're not conducive to people actually wanting to roll out this kind of model more globally in their data schema. But the main thing, of course, is that when you do a delete or an update, you're not having to manually copy the old version of the row, stick it in an audit table or an archive table. It's always there and transparent to the users and the developers who are building the queries to be able to access his previous states. And given what we've tried to do, doesn't sound that fantastic, right? It's just 2 timestamps. Essentially, you may wonder why, even after 13 years, Postgres hasn't added this, right? Why is this thing so hard? And I think it's just because it runs very counter to the way that SQL was originally designed and the inertia that a lot of these systems have. So we're really trying to see if there's a way to, let's say, slightly redefine what a SQL database does and the expectations people have for it. Because trying to paper over this on the assumptions that were made in 1970 about the fact that when you do an update or a delete, it actually physically destroys the previous version in order to reclaim disk space, that entire model of thinking is outdated. Internally in the database engine, there's lots of affordances that you'd never even consider nowadays. And you see the rise of all these cloud database systems, which actually just take, say, the Postgres API and they build out their own thing under the hood, right? It's not really Postgres, because trying to change something that exists is very hard, as we all know in software. Hey, Carl.
And Jeremy, have you had any success in how to change people's minds on this topic, like getting people doing a full kind of technological paradigm shift, moving from one way of thinking to the other? Have there been any kind of successful strategies, either from an individual level or from like an organizational level?
Yeah, I think IXDB is just one solution it's one tool you could use to bring this model. If you search on Stack Overflow, loads of people have tried to implement bitemporality in just like their Postgres schema and things. I think what you really need is someone that recognizes that this is a serious enough problem that's willing to make sure that it's no longer a problem for that organization. I think sadly, like the time that people realize that they need this, it's too late. It's like they've already been burned. They've already lost some data. The schema got corrupted. They thought they'd add some triggers that weren't implemented correctly. And now the data's still screwed up. The history's all screwed up. And that's the point at which they're like, okay, let's go see what the research says. And it's too late at that point to save that particular situation, but they'll hopefully have some, vigor to see if they can roll out a more common solution. So that, say that Goldman Sachs ORM library I talked about, that's clearly like a product of people being like, no, we cannot keep solving this in every single application. We have to just build a library or some common service which can solve this. And I guess what we're arguing with XDB is that actually I think the best place to solve it is at the SQL layer. And unfortunately, I don't think there is a better solution or a more ergonomic solution than the one we're proposing. And if there is, I'd love to hear it. And we can down tools, but what we're working on is hopefully the easiest way to consume the bitemporal model in a database. That's really our entire vision. And it's purely to improve the state of reporting. But no, that's a good question. Obviously, as we get more and more success with what we're doing with XDB version 2 and SQL API, we'll have more success stories to talk about how to get it into your organization. As I said, it's open source, and we're working with FINOS to publicize or broadcast these ideas. But yeah, if there's anything else people need from us to help get it sticky and stuck in and tested, we'd love to make it happen and increase the numbers of users that we currently have.
And just a reminder to the audience, if you have any questions, please feel free to utilize the Q&A chat box.
Definitely. Okay. Yeah. Part of the reason why it's not just 2 timestamps that you want to add is because you actually need 4 timestamps if you're going to do this properly. And here we're just doing a select star and just seeing just for one record of essentially one logical row in our table, ID 1. If we turn on all these timestamps, these hidden timestamps columns, we can see that we may have many versions. And in the time series database, you would say this one record has like 1 billion versions. And that's very optimized for that use case, that tick data use case. Whereas actually, I think most applications that aren't just tick data or sensor data, they don't have 1 billion versions, and they may only have 10, 50, 100 versions. And the complexity of maintaining these different timestamp columns is really what makes all the pain happen. And so when you're building your application and you have to keep track of these different timestamps and make sure that you're careful to update and close over previous intervals, that's really painful, at least to do it manually. And we can look at some SQL to how that worked. But suffice to say, the job of XT in our bitemporal model is to remove the complexity of managing these different timestamp columns, make it as implicit as possible. And really this idea of a principled model of change was identified very clearly by Rich Hickey, who wrote the closure language and the datomic database. Has been a huge inspiration for our ideas and thinking in XTDB. He coined this idea of an epochal time model, which is that actually most systems get simpler if you don't try and do concurrency. So anyone who's spent time working with database isolation levels probably has looked at this idea of serializable. And Rich basically says serializable is the right way to do things for most people most of the time. And if you just default to that, you'll have a much better and easier life in trying to reason about information. And so what we have is some constraints that normally SQL, in a normal SQL database, you can have multiple connections, multiple transactions executing concurrently. You have locks and mutexes and these things which allow a huge amount of throughput. But for many systems which don't have very big throughput problems, wouldn't it be much better and much more sensible if we could, where possible, just reduce things down to a single linear order of change? And so we actually took the SQL 2011 definition of system time and made it completely universal across the database and use that timestamp to actually drive the progression of the different versions of the entire database. So not just of a single row, but you can align these system time timestamps and get these very fine-grained snapshots. So here, V1, V2, V3, they can be read independently. They can be passed over a network, and other readers or observers can understand exactly the thing that was seen. That was like a query made at version 1, time 1 can be seen exactly the same an hour later, a day later, just by using the same timestamp. And this is quite a powerful property. And there are some trade-offs. Like for instance, maybe the idea of an interactive SQL transaction is actually runs contrary to that, so we don't have those. But broadly, it unlocks an interesting architectural model, and anyone that's built any sort of event sourcing system will immediately recognize what this is. It's essentially projection from a write-ahead log of events. But these events are internal events, and you don't have to think about, oh, I have an event to correct something that happened in the past. It's no, we just have a SQL API, and it sorts it all out for you. So instead of seeing
sorry. We have a couple of questions there. Unless the next thing. So, like, the first question is, so how do you actually ensure the compliance of ACID or ensure ACID compliance going for there?
Yes, right now we actually use a Kafka log for the sequence of transactions here. So the change between version 1 and version 2 is derived from a message going into a Kafka log, and it's the Kafka durability semantics that we lean on. So we haven't tried to invent our own raft consensus algorithm doing some very large distributed database thing. We're just doing state machine replication based on this sequence of ordered transactions.
And then we've got just 2 more questions, unless it makes sense to go to the next slide, and then we can follow up. They're more about learning more about XTTB.
Yeah, I think probably come back to those at the end if that's right. That'll definitely be time. Yeah, so as I said, this model of having all these different versions, that's not what people want to think about when they're building an application. Like normally you just want to look at the as of now version. So that's what you get with XT. It's filtered as of now by default. And that actually makes it much more usable and useful to people that want to just pick up, say, a Postgres database and just build something that looks like everything else you see on Stack Overflow. People don't want to have to think about these extra timestamp columns when they're not needed. And that, I think, is one of the biggest barriers to actually people taking this seriously and adopting it. Because you may have a chief data officer or chief technology officer who appreciates, yeah, this is a problem, like we need our teams to be storing bitemporal data. But the reality on the ground for the programmers is it needs to be simpler in order to do it right. And it needs to be foolproof or bulletproof. So that's what you see here. This is essentially a filtering of this view here. And if we want to see all the rows in the table, we can always unlock those and see all valid time, all system time. But by default, we would just see the constrained view of now. And yeah, I mentioned already the idea of corrections and retroactivity, and there's this general way of thinking about it, which is that valid time is mutable. It allows you to go backwards in time and make corrections and assertions about things that have happened, but also what will happen. And you can use this to model many different things. Maybe you're looking at some payment schedules or things that happen in the future, some barrier conditions. And it gives you the sense of debugging, but for a business user. So business user can reason about versions in their application, and they're very distinct from row level versions that like a SQL user would see. Like there's a discrete layer of versioning which is ubiquitous across the application. And I've seen this in many systems where, like in a retail example, again, you want to get everything ready for Black Friday, get promotions ready, get the pricing data loaded, but not be relying on batch jobs. Like all of this data has to take effect in the future. And this is a quite powerful use case as well. Another way I think of describing it is change data integration. So change data may be derived from the system you're building, or it may come from many upstream sources. And that's what Valetime is giving you the ability to model. And then the other thing that SQL 2011 describes or defines is this Allen interval inspired algebra. So you can do these temporal analytical queries. So you could say, show me when these two things were true at the same time, or when this condition wasn't true, based on the entire history of everything that's ever happened in the database. And this can be very useful for any kind of forensic analysis of state. And then how does this all apply in particular financial use cases? There are things like reconciliation, which I'm sure everyone has done or looked at some point. And more often than not, what you're working with is a series of evolving states and having to map the counts or the balances relating to those states and checking that over time that the things add up at the right amount. And at the end, everything's balanced. But in order to do that, you have to really understand all the different parties involved in who's updating those states. And of course, the more complex trading environment you have, the more things you have to reconcile. And a lot of that is just based around this view of time, multiple states over this timeline. And that timeline needs to be the valid time, not the system timeline. It's the system timeline is the timeline of the physical system, time the data was inserted into the system. What we're looking at here is really the modeled reality. So anyone that's implemented a reconciliation system has probably already created a half-baked bitemporal model in their application. I've already mentioned risk systems. This is where we've spent a lot of time at JUXT working on snapshots and tagging versions of data and joining risk reports up with other kinds of regulated reports. And we try to document as many of these cases in our documentation. So you can browse through this, have a look. I'd love to hear your feedback or thoughts on the way it's presented. But I've tried to capture a lot of those use cases around risk as much as possible. But then the other hot topic, which you can't go through a webinar and not hear about, is machine learning, of course, which is perennially important. And I think only getting more important over time. And what we are able to do with bitemporality is to simplify a lot of the things that have to happen in order to build a robust machine learning model and do your back testing. And there was a paper written by some people at Hopsworks who build these things called a feature store for machine learning pipelines. And they talk about how they use DuckDB, and they've got their own other key value database, RonDB, and they use those for feature serving, both real-time feature serving, but also doing back testing of algorithms. And there's actually a comparison with SQL 2011 at the end of the paper where they say, well, you don't really need this. And at scale, it maybe is cheaper to do it our way or whatever. But essentially what they say is, it's very important the algorithm can understand the history of the data timeline, the valid time. But it's also very important that you can rerun the algorithms to be very consistent and know that you're looking at the right, or that they were trained on the right version of the data. And so all these feature store systems essentially solve this time travel problem as well in different ways. And I think Kent Beck, who people may know, has written many books and was key to the XP initiative many years ago. He wrote this summary called Eventual Business Consistency, which is actually a whole different framing of the word bitemporality. And he talks about how, and isn't it great if what's in the system gets as close as possible to what actually happened, because costs go down, etc. Customer satisfaction goes up. And I think that is a key recognition that most systems could really benefit from this. So I'll just run through the last couple of slides and we'll come to the questions. So what we've done with XTDB is to say, Postgres, it's great. Lots of people say, use it by default. But actually we think in certain domains, wherever you have a regulator breathing down your neck and all these big audit requirements, it's almost a risk to actually use Postgres, because you end up having to build all of these reporting affordances on top. Like if you already solved that and you can just repeat that everywhere, great. But otherwise, if you're just telling an organization use Postgres, it doesn't have temporal tables. It doesn't make this easy. And Postgres is actually quite old as well, right? It was designed, best part of 40 years ago, and made all these sorts of assumptions about the number of cores, how threading works, the fact that disks should be local. And as I've mentioned already, in the cloud, you have a lot of these cloud providers now giving you something that's Postgres compatible, but in actual fact, it's not really Postgres, and you are, in a sense, locked in. And I had this really interesting conversation with a guy called Victor Lice earlier in the year on a podcast, where I just asked him very bluntly, what do you think of the future of Postgres? And I love this response, because he says, I don't think that it's really possible to save it, because technically it's not like it's not using it's not making the most of the way modern hardware advances have moved forwards. So it's in a bit of a dead end architecturally. And so clearly there's an opportunity for disruption in the space, and that's what we're trying to do with XT. And in that view of the world, we've added Postgres compatibility. So you can take any Postgres driver and boot it up and use XTDB from that. And I will just have this slide, and then I'll switch to another little demo, but we can stop for questions as well. Yeah, in summary, how does XTDB accelerate as of reporting? I think the word accelerate doesn't necessarily just mean performance. It's not just about raw performance. It's about time to market. It's about lowering the implementation costs. It's about getting it right more often than you get it wrong. And I think we've definitely already ticked the box on that. If you spend some time playing with the API, we're obviously are working on the performance. The database is like a never-ending performance quest. And I think for this main use case of as of reporting over very large amounts of data, we've already got this primary key temporal index, which delivers on this promise of I just need a timestamp and run this query as of this timestamp. And it could be quite far in the past, and that should be a reasonably fast query. Anything that's on more recent data should be faster, and anything as of now should be as fast as an ordinary transactional databases. So XTDB is a transactional database, but it also gives you this as of reporting capability, which is more commonly associated with analytical systems. So you could describe it as a hybrid transactional analytical platform or processing system, which is a bit more jargon for you. But importantly, it's open source. It's built on Apache Arrow as the underlying runtime using the JVM. And this makes use of columnar processing, which again, that's just not how Postgres works. If you need to do large sums and aggregations on Postgres, there's a lot of deserialization that needs to happen for a wide row, whereas we store the columns separately. It's Kubernetes native and has a nice, healthy roadmap of things we're integrating with now and in the future. And I'll just give you one little bit more of a demo here. So I showed you the FINOS TraderX interface earlier, and just in this video, we break down exactly how it works. So behind each of these panels, you have different queries, and you can see the full valid time as of, and these are parameterized queries. And as long as all these timestamps line up, like the application works. And we're not trying to force everything into one giant query. We're not saying, think about your data model entirely differently. We can take like an existing schema, a project that's already being built for Postgres, and just get bitemporality for free by just pointing it at XTDB instead. And I've got a demo here of what it looks like, say, connecting from a Visual Studio Code. So it thinks it's talking to Postgres because it's using the Postgres wire compatibility. And you can see the view of the tables, the types, the column names, just as you'd expect. And this is using like a standard VS Code plugin. And we can see our schema. We can see our trade data. So this is the internal developer view of the TraderX dashboard. And you can see all the trades are settled, right? So because we're viewing it as of now, select start from trades is getting me all the trades as of now. And if I want to see more about the history of those trades, these valid from columns are there. They're just silently waiting to be used when you need them. And then you can use for all valid time, right? And see the different states. So here we can see settled and pending trades very clearly and that's just 2 entries in the history, but imagine there's 1,000 entries in the history because the trade keeps updating and keeps getting more and more data added to it. And something we've not really touched on is XTDB's support for semi-structured data. So once you start capturing versions of things and you want to change the schema, the question then becomes, well, how do you manage or handle a version change to the schema itself? Should you version the schema, or should you just have another entirely different database? You decant the data. Well, the answer, of course, is to have a database which can handle column additions and things very flexibly. And you see this a lot with things like Apache Iceberg or Delta Lake, where they have support for evolving schema. And this is an important quality. But of course, those kinds of systems, they don't have valid time. And if they did, again, I wouldn't have to be stood here telling you about it. But the valid time is the thing you really want to be doing the as of reporting on. So we'll just run through this a second. We can see here, we can see full audit information. So if a developer does come along and make some update to the application and it breaks, there's a bug, it's corrupted the data somehow, we always have the full access to the history of the trade, including the audit timestamp. We see who made the change to the database, all recorded transparently in that log as we looked at earlier. And if we have some analytical query now want to do, and so show me the late arriving trades or the trades that were adjusted outside of the approved window of 1 week or 1 day or an hour, we have this language to be able to do that. And what might be otherwise a very arduous process to pull this kind of data about how things have changed, it just turns into a 2-line SQL query. And we can skip forward and see.
We're getting towards time now.
Of course, yeah.
And just as we're going to share a couple links here and then go for a couple more questions, I think the explainability angle, FINOS has a AI readiness group that's built a governance framework that's looking at building these threats, risks, and controls. And part of it's doing AI explainability. So it would be very interesting to do some level of evaluation of the tool set there. So if anyone's interested in that as a larger question, and hopefully we can get JUXT to come talk to the team around that, I'll be posting that link into the chat here. The next question that we have is where can people find more information about XTDB, but also where can they find any advanced samples of XTDB online?
Yes, we have a lot of, it's basically all open source. It's all public. We have xtdb.com, which links to the documentation, links to this thing called Play, allows you to just run very easily, like some example SQL queries. And here I'm running something which emulates a time series database, but as I showed, the docs have all these other use cases, which anything I've heard of about the way time is used in a financial application that a database could accelerate, I've tried to document it there. So hopefully you can see some good examples. I can just show you the docs page. For instance, so all the documentation is runnable, and we have all this kind of how does backtesting work, and like complex queries, or we have one about understanding P&L, and you can simulate different parameters to the query and see how the different as of timestamps change based on the things. So very similar to the TraderX example, just without all the UI stuff. So walking through how the SQL works. And
awesome.
xtdb.com is the website.
And the last thing we'll share here is, so coming on January 21st, you can see Jeremy talk some more about a JUXT hosted webinar. We'll post the link here, but so here's the link to register for that. As a reminder to everyone on the call, this is the Open Source in Finance webinar series, which is a member benefit. So if you are a member, again, with an open source project, please contact us, and we'd love to be able to facilitate you giving this kind of webinar to the community. Jeremy, any final thoughts from you?
Thanks. I think you covered that. Yeah, we have, like I said, like this documentation, we have interactive examples, anything that provokes any sorts of thoughts in other people on this call listening, or you think other colleagues might benefit from hearing about this stuff. I'd love to just network a bit more and try and find some good people to partner with, because as we roll out into general availability next year, we want to make sure that we're ticking all the boxes that people need in terms of security and auditability and other kinds of ways. Yeah, it would be really useful to have those conversations now. We are going to be going into general availability next year, so please join that webinar if you're interested to hear more in January.
Excellent. Big round of applause for Jeremy and the JUXT team. Been an absolute pleasure to work with from everyone on the FINOS side, and between the tech sprint and getting ready with this webinar. So everyone in the community, please make sure to reach out and check out the docs in order to learn more. With that, we're concluding our second Open Source in Finance webinar series. Again, please let us know if you'd like to get added to the list. And with that, happy Wednesday, and hope everyone is ending out the year